We will be looking at the various perspectives of what it takes to manage data, focus on data, and be able to drive decisions based on the outcomes of those particular data. I've had an interesting career in the past 25, 26 years, helping executives to grow their business, to develop their organization, to transform, and to take decisions based on AI and data. So sometimes we ask the question, when we say wrangling, what do you mean by wrangling? I'm sure some of us are used to watching once in a while the Texas sports, the rodeo sports, where a cowboy rides on a bull and tries to conquer the bull, as the case is. Usually that particular sport is usually referred to as wrangling, being able to wrangle the bull to agree to do what the cowboy wants at that point in time. If you check the dictionary, wrangling means arguing a point to a position where the person you're arguing with agrees with you and forms in line with what you've said at that point in time. The process of being a form and return the way that so you wrangle the data to comply with the way you want it to be at that point in time. Whether it is a desired format that you're looking at or a desired structure that you want the data to be able to represent at that time. So that is what we refer to as data wrangling. Now, even though you wrangle this data, the idea, what's the motive behind wrangling? What you want to do is to improve your data quality and be able to achieve more results from your analytics. But most importantly, data wrangling is very critical for data analysts for several reasons. One of the reasons why data wrangling is critical is that it helps you to combine resources across board. It helps you to clean irrelevant or blank data. You know, sometimes when you capture data, you notice that that data have space. The people you asked to fill it did not fill everything that you expected them to fill. And you need to do analysis based on some of those empty fields as the cases. Or there are inconsistencies in the data. An example is inconsistency in the structure of dates. You were expecting month, day, year, but you're seeing day, month, year. And sometimes another person will enter year, month, day. And so it is scattered at that point in time. So you try to address those inconsistencies in structure. It also helps you to be able to look at, to see if you can detect fraud, right? Data wrangling helps people in the financial industry, the fintechs, the banks, to be able to detect fraud. Once they see an anomaly in the transactions that is going on, their data analyst in-house is able to identify that, look, this transaction should be flagged at that point in time. It helps with data security and helps us to recognize value in various areas. Also, data wrangling is very important because it helps us to accurately and consistently output the data that we want. It helps with compliance with regulations. Because sometimes there are certain regulations from government on what must be captured and how it should be captured, or what must be stored and how it should be stored at that point in time. So data wrangling is a powerful way of ensuring you achieve this. It also helps you to analyze your consumer behaviors, especially those in e-commerce, those in marketing, those in sales. You're able to generate data on the various touch points when your customers have engagement with you. And if you follow all those touch points, you'll be able to identify clearly what the customers are interested in and what they eventually get and what they need to buy at that time. And then finally, there is less time in preparing data for analysis, and you can see trends within that particular data that you have structured at that point in time when you start doing your data analytics. So data wrangling is very important. For the data professional, for the data analyst, this is a critical area he needs to pay attention to and then know how best to use it to drive process and drive better results. But what tools do you use for data wrangling? You can use almost any tool that is used for data analytics. The most common tools for data wrangling is your Excel, Microsoft Excel, right? If you can capture the data in Excel, or if you can or you can use other platforms like R, like Power BI, like Python, right? To be able to wrangle your data at that point. And there is a stated clear step of how to wrangle data. Usually it is 6 steps. If you go through any data analytics course where they are discussing data wrangling and transformation, you will identify these 3 steps. These 6 steps. I am going to use the steps that is recommended by Harvard Business Review to illustrate what is required when it comes to data wrangling. According to Harvard, Harvard says that there are 6 steps through which you can walk through your data wrangling. One is discovery. And in discovery, it requires you to familiarize yourself with the data that you have at that point in time so you can understand what you might use the data for. So once you receive data, let's say in Excel sheet, before you start any calculation or manipulation, what you do is to go through the data, scroll up, scroll right, scroll left, examine the data by looking at it very briefly. One of the things I do whenever I have data in Excel is to do quick analytics on it. Do quick statistical analytics. I find the mean, median, mode of it, find the statistical average at that point in time, do a standard deviation, do a chi-square on it, do a linear regression quickly. In 2 minutes, I've done this analysis. I have an idea of what the data is. Then I know what to look out for at that point in time. Then the next thing is to structure the data. Is the data very structured? All right. Are there some missing elements? Are there some areas that are not well put together? Are there some you're expected to see 5 characters, but you're seeing 3 characters or 2 characters, as the case is? Then you clean the data. You remove any errors that you find in it at that point in time, or anything that is going to distort your analysis, missing data points, extra data points, misaligned data points. Remember when your structure is like you have a column in your Excel sheet that is supposed to contain bank accounts. And you look at bank account, normally bank account numbers are like 10 characters. I don't know if I am wrong or right. For those of us who always calling account numbers. So let's assume that bank account number is like 10 characters. If you scroll through the data, you can notice that some are 9, some are 8, some are 11, some are 12. Those ones is an indication that the data is not structured. It's not in a structure and format you expect it to be. Or it's phone numbers. Some people, when they write their phone numbers, they do 0809. Some other people will write +234 0809, as the case is. But if you put it in Excel, if you put plus in Excel, Excel assumes that you're doing an addition, right? Excel, if you indicate that you're not doing an addition. Or if you start with 0, Excel will trim out the first 0 and give you 809. Take the figures from 8, where it starts at that point. So you see, different people entering their phone numbers, you will have a final version that is not consistent at that point. That is why you need to structure and clean that properly also. Then you might also want to enrich the data, right? You may augment the data. There are certain data that you feel that are not well put together. You may need to augment it, as the case is. Then you verify or validate that your data is consistent, the structure is clear. Once you have gotten at this point in time, then you're ready for analytics. You can then publish and make the data available for us to do any analysis that we want at that point in time. Now, that's what is involved in data wrangling as the case is. All right. Now, I'm sure some of us capture data in various platforms that we're able to use. Please share in the chat box. What is the primary data source where you capture your data in your various institutions? Where does data enter into? What platforms do you use for your data? What are the platforms you use for capturing data? Yes, share in the chat box. What platforms do you use to capture data? Google Sheets, exactly. Thank you. In recent times, online sheets are superb. Thank you, Ben. Yes, what other platforms do you use for capturing data? All right, Google Drive. Okay. Interestingly, if you have a Google form, so to speak, you can connect it to your Google Drive. So as the form is collecting, it is sending it to that Google Drive at that point in time. Thank you, thank you, thank you. So, interestingly, Google is becoming mainstay in capturing data. Some other people use Excel. Some people use SQL. All right. Some people use other means of database to capture some of the data that they use. In our discussion today, we shall look at what it means to process data. We'll see how you can clean data, how you can handle missing and repeated values in your platform. You see how you can take out of outliers. There are some outliers that you see. An example, on the average, most people that you meet, their height, the average height of most people is between 5.5 feet and 6 feet. But once in a while, you run into somebody that is extremely very tall, 6.5. I've seen somebody who is 6.8 feet. Now, with that kind of height, he or she is going to be very tall amongst every other person. Then you also run into other people who are not up to our 5.5 to 6 feet. There are some people who are 4 feet tall, who are 4.5 feet, so to speak. So those two extremes, we refer to them as outliers. Outliers, when we're capturing data, as the case is. Then there could be errors in typing data. You wanted to write the character called number. And so when you're writing NUMBER, the E, you made mistake and type the number 3. That's an error in that particular record at that point in time. Or you're trying to enter date of birth. The person's date of birth is February 1, 2001. But when the person was entering it, he made a mistake and wrote 1, 2. And it was read as January 2nd, 2001. So that's an example of errors that you'll find. Then if we have time, we shall look at how you can scale data and how you can use Python, right? Matplotlib and Pandas to be able to do your data wrangling as the cases. Thank you for sharing in the chat box. So let's start this conversation by looking at data processing. All right. So when we refer to data processing, what are the various elements inside it? One, every data must have data types and clarity of the forms. Most times, data types are two. They are either numerical data or they are categorical data. Numeric data are usually data that have numbers. They are continuous. They are discrete. Things like interval, a range, a ratio, an ordinal, right? A period, okay? It could be a date, it can be a week, it can be a month, it can be an age, it can be a number, it can be an order, first, second, third, right? All of these are called numeric data. It could also be a categorical data, maybe your coding system. An example of a categorical data is staff ID. One of the organizations where I worked in, our staff number was SN. SN is the name of the organization. Then 2025, which is now the year. And then the next three numbers, XXX, is the number according to the date according to the number that you joined the organization. So the first person that joined the organization in 2025, his staff number is going to be SN 2025001. The next person that onboards, that resumes, becomes 002. We'll continue that way till the end of the year. Maybe the last person that year, we recruited 152 people. ID for the year, the maximum is going to be SN 2025152. Then once it comes January 2026, the numbers will reset again. It starts at SN 2026001. That's what we refer to as you use that as a coding system. You also find coding system in manufacturing, in the batch number of products that are made. So those batching number are examples of coding systems that you also find at that time. You also look at certain sizes of products and services. those sizes are also a coding system that you receive. For example, your car tires. If you look at your car tires, there's a number first, then there's an R, and then there's another number. You can see 195R15, 207 or 205R18. The number before is telling you about the profile of the tire. Like that is whether the tire is wide or slim. While the R is telling you whether the height of the tire, we usually call it the diameter, the radius of the tire. And usually we'll talk about a car having the wheel. The alloy wheel is 19 inches alloy wheel, 18 inches, 20 inches. It is that R that determines the inches that of the tire that will fit on that part. So it's called a coding system. Now, there are other kinds of data you'll find. Distributed data, text data, data that you gather from the web, audio, right? Images, PDF. Like if you're doing recruitment and you ask candidates to submit their CV through a Google form and they upload and attach that CV, there's a record, there's a file, there's an Excel sheet on Google that it stores those particular things. So each of those things have a reference code at that point. So that's an example of that particular data. Another thing you should note when you're processing data is the quality of the data. You are very interested in the quality of the data. So your data processing helps you to ensure that data is clean and usable. And when you're looking at data quality, there are different ways to measure quality. One is accuracy. Accuracy is asking, is the data very accurate? Can we count on the data at that point in time to say that you have an accurate data that you're using at that point in time? So accuracy is something to pay attention to when it comes to data analytics. All right, so we're looking at, are the texts right? Are they wrong? Is it accurate or is not accurate? Then there's completeness. Completeness, on the other hand, is asking, was it recorded? Is it available? Are there missing parts in it at that time? Then consistency. Data consistency refers to whether some part of the data has been modified. Is it the length it is supposed to be? Is it dangling, not complete at that point in time? Yeah? Then there's also timeliness of data. Did the data come when we expect it to come? So timing is very critical. There are certain data that if it comes after a particular time, that data is useless to us at that time. For example, did we get an update on the data at the right time we expected the update to come? Or believability, can we trust the source of the data? Is the data true? Is it accurate? Right? Is it correct? Is it a platform or a source that you have confidence on that particular data? Then the last part of data quality is interpretability. What does it mean? Can it be understood? Can you explain it to another person? Is this easily understood when we share that data with other individuals at that point in time? So that's an example of data processing as the case is. Okay. All right, good. Now let's look at data cleaning, the second part of our discussion today. So data cleaning, another word for data cleaning is data munging. All right. Is it that you're data munging or your data wrangling? So data is rarely in the form you expect it to be. It doesn't always come looking neat, looking presentable, looking the way you expect data to be at that point in time. It is always almost dirty, right? You must make adjustment. Except if when you're designing the source of the data, you have put system in place to ensure that anything that is entered must be accurate in that particular area. Imagine your banking transactions. A big bank like, say, First Bank, GT, Zenith Bank, if you ask them to download their transaction record, it will be more than hundreds of thousands of transactions per second. It will be more than 1 billion transactions in a month. Most probably it will be into zillions of transactions. Remember when you're entering that data, sometimes when you enter an alphabet in where number naira is supposed to be, it will tell you inaccurate format, or it will refuse to go at that point in time. Or if you're typing the description, and this is common with some of the banks in their online platform, when you type the description and it's longer than expected, it will tell you that it cannot take the number of characters that you specified. That's an example of a pre-planned platform that prevents you from entering data the wrong way. So data wrangling is typically the most consuming part if you're a data analyst. Cleaning data, wrangling data to keep it in order for analytics is the most difficult. The main analytics part where you draw graph, you draw diagrams, you present the data. There are tools today that once you plug the data, the graph appears. But you see that part of cleaning the data, that's where a lot of work is. And that's where we need skills when it comes to data analytics. And data wrangling is an iterative process. It's something you do often, continuously. You continue to wrangle data until you discover through visualization at that point in time. Sometimes what you get is not in the format, in the model that you want it. You expected the graph to behave up, down like that, but the graph is flat, straight. So it tells you that something is wrong in that particular data. Or you get the graph and the thing is running straight from the beginning at the bottom, it is crisscrossing straight to the end. Again, it tells you that something is wrong with that particular data. So you need to fix the problem, the modeling problem that you have at that point in time. So when we say data is an iterative process, what do we mean? Let's illustrate by means of a diagram. So there's business understanding. What does the business want to do? Why are we doing data analytics, right? Okay, so you identify the objectives of the project or what we're doing at that point in time. Then you move to data understanding. Now we've collected the data. We are reviewing the data to understand the data. Remember, you can see this loop. You can see this loop going back. It's asking you, does the data format comply with the business issue that we are trying to address? If not so, we need to do something. Then you now go to data preparation. This is where you select, you clean the data and identify gaps and fix those particular gaps. When you're done with preparing the data, you now begin to model, manipulate the data, draw conclusions. If it is not working very well, you go back to preparation. That's why, again, there's a second loop here. You go back to preparation and see if you can clean and tidy up the data more at that point. Then you make an evaluation of the model you have presented. Does the model answer the business question here? If it doesn't answer the business question, we'll go back to the business question and go and understand it very well at that point in time. But if the model, after evaluation, answers the question, you deploy it. You can then send copies, versions of it to the executives in the organization to say, okay, this is the final report. This is what our system has shown that has happened over time at this point in time. And then we'll make that presentation to them. This is the process of cleaning and transforming data. So what are the small processes involved when we are cleaning data? First, you clean data, you integrate it, you reduce it. Sometimes you have to shrink data, like that banking transaction data. They don't need the zillion records of data. They can't be carrying zillion records of data. So they must have a way of summarizing that particular data, right? They may summarize it according to day, monthly transactions, quarterly transaction, or they may summarize it based on, say, branches. Abuja transactions, Lagos transactions, Ibadan transactions, or they may summarize it based on their target customers, retail customers, corporate customer transactions, right? SME transactions, high net worth individual transactions. So that's an example of data reduction at that time. Then you can then transform the data at that point. Remember, at cleaning, when you're cleaning data, sometimes there might be noise. There's what we refer to as data noise. There will be missing values, noise in the data, and then there are outliers that we need to remove and sort out at that point in time. Those are examples of some of the C in data analytics. Now, when you're cleaning data, in the real world, data is almost always dirty. Anytime you collect data, guaranteed that there must be some dust inside it. There must be some dirt inside that particular data. So there's a lot of inaccurate data, like maybe instrument fault. The instrument you use to measure, like when we were measuring the height of the people to find out how high they are, the ruler, the tape we're using to measure has chopped in one side. So 0.5 centimeter is missing from inside it at that point in time. So that's an example. Or you could also notice that when you're measuring it, there is human error. The person that is typing the transaction wanted to write 500,000. He now made mistake and forgot to put extra zero. He wrote only 50,000. Or there are mistakes when he wants to write 10,000. He wrote 100,000. So those are errors you find from a human side. Then there are also errors from a computing point of view, as the case may be, right? And these errors can also affect the final data that you have. We refer to this as data that needs to be cleared. So one of them is incomplete data. Values are missing, attributes are not there. It contains aggregates that you don't want. An example, one of the records in the document you're trying to get is called occupation. It's called occupation, but there's no occupation inside it. So if the occupation is missing, you cannot make analysis, deep analysis of people in various occupations. Or noise. An example of noise is that we expect salary. We need to enter salary data. You're not seeing salary minus 200,000. Minus cannot be salary. Whenever you see a minus, that's a clear error. We call errors noise, right? Because it distorts our data at that point in time. Or there are inconsistencies. You ask the person, what is your date of birth? How old are you? He now says his date of birth is March 7th, 2010. However, in saying that his date of birth is March 7, 2010, he now say age, he say 42 years old. That's not possible. How can somebody who was born in 2010 be 40 years old? So that's an example of a mistake or inconsistency in data. Or we say, rate this thing on a scale of 1 to 5. The person now rate A or B or C. It is not in alignment with the rating we asked for initially at that time. That's an example of what we refer to as inconsistency in our data. Or you may have duplicate record. I say submit your record. Then you submitted first time, internet was disturbing you. You did not know whether it went or it did not go. You now sent it the second time. Now the two records you submitted, in the first case, you made one mistake or you changed the data in one particular area. When you now retype it again, you entered a different data. So the two records are not the same. So we are not sure again which one is the correct one. That's an example of inconsistency in data. Or there could be intentional effort to mislead data. So you disguise or put in some missing data. An example, they say, what is your date of birth? And the person did not enter anything. Then you who is doing the analysis, for everybody that did not enter anything, you put January 1, January 1, January 1. For all the missing data of date of birth, you put January 1. That is an example of intentional error being introduced to data. Now, why is it important for you to clean data very well? Well, it is very critical for you to clean data because data cleaning is the number one problem in warehousing data, all right? It is very important that we ensure that we clean data very well. And data preparation, data cleaning, transformation is like 90% of the job in data analytics. If you can learn this, if you're pursuing a career in data analytics, don't bother about graphs, presentation, and things like that. Hold on. Learn how to clean data. Prepare data for analysis very well. If the data is of not good quality, then you cannot get good results from it at that point. So those are some of the things you need to learn in order to clean data as much as possible. So you can share on the chat box, in your experience, where have you seen dirty data before? What kind of data that is being captured? Did you notice that the data is dirty? Which other ones have you seen? What platforms, what kind of data have you collected in the future that you saw some of these things we've mentioned that is dirty inside the data? What are some of them that you've seen in the past, dirty data that you've seen in the past? Please respond. What are some dirty data you have also seen in your own record? In your data analytics in the past, what are some records, some data you are capturing that you saw some data. Yes, exactly. Null data. Sometimes there's nothing. All right, nothing is entered at that point in time. And if there is no filter to ensure that they put something, they can submit null at that time. All right? Or some people, you say enter your name, they'll just write J, only J inside it. Or in some cases, you say, please type your address. They just type gibberish, JPQSROs 1, 2, 3, 4, 5, and then they press submit. And the system accepts it at that point in time. That's an example of where people enter gibberish as a data entry at that time. And that's not right, right? Now, how do you handle missing data or data that is repeated in your data analytics? How do you handle this? Missing data and repeated values are usually data that are common. They are the major problems you always find in data wrangling. Data is always missing or data is always repeated. And many machine learning algorithms are not able to deal with missing data at all. They are not able to achieve those records at that point in time. So you see that it does not work very well, all right? Many machine learning algorithms do not know how to handle missing data. Once they see missing data, either it crashes or ignores it, and by crashing or ignoring it, it gives us problem at that point in time. So it's important that we pre-clean data. You see, this is our AI platform, ChatGPT, Gemini, and co. Before they loaded those things with all the data of the world, there were projects of various individuals across the globe that were busy for several years cleaning the data that was online until the data was clean enough to a percentage of integrity before they uploaded it into those AI. And that is how the AI is able to do its analysis and then respond very well. Repeated values also can create bias. It can create the wrong average when we take average on the platform. It can give the wrong information of frequency, number of occurrence when we have repeated values or errors like that. So it's critical that we pay attention to it. Here is a table that shows you an example of some missing data. Can you see here? In column 3, we have a missing data here. So what is the gender of this particular person, right? This particular information is missing. We don't know the gender. In column 5, we also have a missing information. Is it small? Is it medium? Is it large? Question mark. We don't know what it is at that point in time. So those are missing values. Can you also see here, although here it is missing, and I suspect this is age. The record is missing here, but it has been replaced with a placeholder called not applicable or not available, as the case is. And sometimes in data analytics, it's allowed for you to enter this information. What we'll simply do is when we're doing the analysis, we shall ignore this row in doing our analysis at that point in time. Or in this particular case, when we are checking gender, we shall ignore the entire record in this place because this is missing at that point in time. So that's how you handle some missing values. So data is not always available. Sometimes many data sources do not present you with all the information you have, especially customer data. Customers don't like filling forms. When you give them forms to fill, they always go to the compulsory ones. Those are the ones with the energy to fill it well. So they just enter anything inside it, just to let them go at that point in time. Now, other causes of missing data, like we've said initially, is that the equipment might be faulty, the data is not properly recorded, or when it was recorded, somebody by mistake pressed delete. Just like in your Excel. If your Excel is open and your cursor is inside and you're chatting and discussing with somebody, you do not know when you by mistake press space bar. When you press space bar, it cleans the entry in that particular cell. And you don't know you've cleaned that entry, you just click save. So instantly at that point in time, data piece has been deleted. Or the data was entered by somebody who misunderstood the question. all right? And then that particular data came in the wrong way at that point in time. So those are some things you will find. Or that we don't even have the history of the data. There are different reasons why we may have this particular problem. So in data wrangling, how do you handle missing data? What do you do to deal with data that is missing at that point in time? Well, once you have missing data, what you should do is, one, remove the rows. If you can afford to remove the row entirely, you can ask your data manipulation system to remove the row. An example, if you're looking at customer database, and then you know the unique item is customer ID. If the customer ID is missing, then the entire record is useless because you don't know where it belongs to. Or you're doing an analysis based on branch by branch, but the data did not contain information at branch, no branch ID. You remove it, so it's easy to remove that one. Or you're doing analysis on staff data. So when you're doing a record on that particular staff data, and you notice that the staff record does not have staff ID, so you don't know whose staff it belongs to, so you can remove it. So you can remove rows when you're treating data. You can use a substitute value. Remember the previous exercise we gave earlier, we did not applicable or not available. So you can use that. Or you can take an average of other data, right? And use that particular average to fill what is there. You can do what is called forward fill or back fill. Forward fill is that you take based on progression, geometric progression or arithmetic progression, you know what the next number will be. Or backward fill, you take what was the previous figure, you use it to fill at that point in time. So those are possible things you can do in order to handle missing data at that point in time. Now, depending on the system that you're using, in Power BI, as an example, you can do an automatic handling of missing data. So if there's a missing data in a particular column, you can tell Power BI or Excel to automatically replace it with not applicable or with a predefined number at that point in time when you're loading data and transforming data, all right? But if you do it manually, it can be tedious and sometimes it's infeasible. What if they gave you a bank record and bank records are heavy? It's not just 1,000 rows. It's not just 30,000. Even your Excel cannot carry it. All right, it's running into millions of records. So you cannot carry it on Excel at that point in time. So you can't be going through one by one to look for missing data. We will not finish today. All right. So you may use a platform and use a global constant like unknown, not applicable, not available, and use it to apply to all of them at that point in time. So the most probable value also can also be used. You can use an inference as a way to fix that particular data. So what have we agreed? So let me look at how to clean data using various platforms. Now, if you're using R or Python, this is the formula for it. In R, you use what is called is not applicable. You see, is NA means is not available or not applicable. Whenever it finds a data point that is not applicable, then it will perform the action that is inside that bracket. In Python, on the other hand, it's called pandas.dataframe.isNull. Like Ben shared with us earlier. If it is null, right, that means data is missing, then it is going to run the routine, maybe replace whatever you want at that point in time. Here is an example of what I'm talking about. So you can see in this particular place, we have repeated data. In this place, we have repeated values, right? And you notice that between this and this, the data entry is different. So this inconsistency, we are not sure which is it. And between all of this, it was telling us that they were female. Now it says it's a male. So we have a problem with it at this point. So these two columns gives us difficulty in accepting this particular data at this point in time. So something is wrong with this data outcome. So you must find a way to fill it and address the constraints of that particular data. How do you handle repeated values with your formula? Again, let's share another formula. First, you can use R. If you're using R, says data frame is duplicates, then it will handle its duplicate. So once it sees that the record is duplicated, it's going to handle that particular duplicate. What if it is Python? For Python, Data frame drop duplicates. What it will do is to delete or remove any duplicate it finds. It will not carry it along with where the analysis is going to do at that point. An example is here. If you run this through that Python and say data frame drop duplicate, it will drop all this record, 1, 2, 3, 4. It will remove them and give you the other ones that are correct at that point in time. So that is how Python handles it. However, R is more flexible. R allows you to tell it what should do. So data frame duplicate, you will not tell you what to do. Should I drop it? Should I change the numbers? What should I do at that point in time? But in best practice, what we always do is we remove the duplicates. We don't want to have issues with it at that time. The last one is cleaning outliers. Cleaning outliers. Cleaning outliers. Yes, exactly, Titi. If it were Excel that you're using, you can do conditional formatting and it will show you duplicates that are found inside it, right? It will color all those ones at that point in time. And you see exactly what to do in order to clean up those particular data at that time. However, there's another function in Excel that you can use to clean duplicate record in your data. In Excel, under the data, if you go to the data ribbon, you'll see something that's called duplicate. Once you've highlighted the table, right, and click on the column, once you highlight the table and click on that duplicates, right, it is going to give you a dialog box and give you the header of all the data columns in Excel and ask you which of them do you want to find duplicate on. Then you select the ones that you want to find duplicate on. What it will do is it will remove all the duplicates and shrink your data to a useful format that is good at that point. Thanks, Titi. So that's an option if you're using an Excel platform. Now, how do you handle outliers? You know, data that is outside the range. Human beings are supposed to be 5 feet to 6 feet tall. Then you have somebody who is showing 8 feet. The data is showing 8 feet. That's a giant. And I'm not sure there's any normal human being that is 8 feet tall. Or the data is showing that the person is 2 feet. Is he a baby, as the case is? So that's an example of outliers at that point in time. Or perhaps entry-level salaries. We are looking at salary record of our organization. So we expect that entry-level salary is between 100,000 to 200,000. Then you now see somebody that his entry-level salary is 1 million naira. That's an outlier. Or you see someone who is entry-level salary is 10,000 naira. That's an outlier at that point in time. How do you handle such type of outliers? Or maybe you capture data. You're working with FRSCN, that is Federal Road Safety, and they gave us data of car speed, cars that passed at a traffic junction. The speed, the camera caught the speed that they were passing at that point in time. So we are seeing speed of 80 kilometers, 90 kilometers, 70 kilometers, 100 kilometers. We now saw one. You now saw a record that the speedometer, the speed was showing 350 kilometers an hour. That's an outlier. A car that is running at 350 kilometers an hour, it will have almost flown and taken off at that point in time. At least that's fast. That's faster than the speed of a jet, the takeoff speed of a jet, as the case is. So that's the example of how you identify outliers in your data. So what are outliers? Outliers are errors that cause bias in our data. And there are many reasons why we have outliers. Some of them is error in measurements. We didn't measure it very well. The person that was typing that 350 kilometers when the car passed had wanted to write 150 kilometers or 100 kilometers, and he made a mistake and wrote 350. And that's an example of an entry error. All right. It could be the measurement instrument, that camera that is capturing cars passing. The sensor is faulty and is giving us the wrong record at that point. All right. Or maybe we transpose the data. And by transposing the data, it has given us a wrong value at that time. So there are different reasons why you can have an error. Whatever the case is, you can use summary statistics. Like I said earlier, I do summary statistics for my data before I start work, because it gives me an idea, a bird's eye view of the entire data at that point in time. Summary statistics gives you mean, median, mode, standard deviation, right, of your data, minimum, maximum, range, of the data that you have instantly. And that gives you an idea of the data that you have at that point. What if I did a summary statistics on my speed of cars passing on Third Mainland Bridge? And then I saw that the mean, which is average speed, is 200 kilometers. That's crazy. 200 kilometers an hour as average of speed on Third Mainland. The car will have been jumping like this on top of the bridge, as the case is. So instantly it tells me that there are some data record that is more than 200, and I need to investigate that particular one. Or what if I did minimum speed of, I found the minimum and the maximum, and it showed me that the minimum, a car was doing minus 10 kilometers an hour. Stop, if you park your car, it is called 0 kilometers an hour. For it to have minus, and maybe the car is reversing back or something like that. That's an example of an outlier. So even before you do analysis, simple summary statistics helps you to understand what is inside your data. Another thing you can see with your data is what we refer to as noise. Noise. Noise are random errors or variances in the data that we measure. And it can be due to the fault of the equipment or the instrument or the person entering the data, the person doing the transmission that transmitted it from one place to another place. Maybe they downloaded it as PDF. You now copied it from PDF to Excel. I know sometimes when you copy from PDF to Excel, the data does not come in the same format. The table can scatter when you copy it at that point in time. It could also be a limitation in technology, right? Maybe where you copied it from, the maximum columns it can take is 5,000 records, but you're copying 6,000. So most probably it will truncate. It will copy the first 5,000 or it will copy the last 5,000, depending on whatever the case is at that time. It could also be inconsistency in naming convention. If you have tried uploading contact lists to your contact address on your phone number, on your Google, you will notice that for some platforms, they have first name, last name. For some platforms, they just have full name. So it does not break it down into those particular positions. And so the system will only capture what it wants or what it can get at that point in time. Other causes of noise includes duplicates, inconsistent data, or incomplete data. Now, how do you handle noise? Simple. There are different ways of handling noise. One is to bin. By binning your data, you can handle noise. What does binning mean? Partition, arrange them in lowest to the highest, and then partition it into equal frequency. Maybe first 10, second 10, third 10, fourth 10. That's called binning. And it's a good way to smoothen out your data and find out where you have issues with it. Or you can do statistical analysis on it and find out the regression and try to smooth it using regression functions. Other things you can do is to cluster it to detect and remove outliers, right? And then you can also do it by inspection, by scrolling through the data if it's a small data, right? To find out if there are issues at that point in time. So you can deal with those outliers. Now, for what I've mentioned here, I'm going to talk about binning a little bit because I'm sure binning might be new to some of you if you're not used to data analytics. So what is the binning method when it comes to removing noise and smoothing data? So here's an example. So I have this data. So this data that we have here, just arrange it in order from this lowest to the highest. You can see 4 all the way to 34. It's been arranged in order. Sort it from lowest to the highest or from highest to lowest. Doesn't matter. Just sort it in terms of cardinality. Then partition it into equal bins. So here I've partitioned it into 5. So you have, into 4. So the first bin is 4, 8, 9, 15, bin 1. Second bin, 21, 22, 24, 25, bin 2. Third bin, 26, 28, 29, 34. By creating this bin, I have partitioned the data, is in bins, right? The next thing is to smoothen the bin, right? What is the average across all these particular things? The average is 9. So I'll arrange the 9 across it. The next one, what is the average here? The average is 23. And then the last one, the average is 29. That's an example of binning by smoothing. Now you can then look at the boundaries. You can smoothen by bin boundaries. So you have 4, 4, 4, 15. Any data that is above 15 is outside this boundary of this particular bin. This other one, 21, 21, 25, 25. Anything after it is outside that particular bin at that time. So those are examples of how you bin in order to generate your data. So what have we covered in this particular case? We've looked at how you can handle outliers in your data. So you can have discrepancies, check whether it's overloaded, check for the unique value of the data that is presented at that point in time.
It's 12
o'clock. You can scrub the data. We usually use the expression data scrubbing as a way of washing or cleaning the data at that point in time. And then you can migrate the data to different platforms also. So those are some things you can do. Now, outliers, when you draw your graph, you can see very clearly which data is outside the zone that is expected at that point in time. Okay, so it's an example at that case. So different outliers can happen. Maybe you're checking for CEO salary and you see an entry-level salary inside it. So that's the problem. Noise, you're looking at people's age. You see somebody who is 200 years old. You know that's not practical. Is he a tortoise? So that's deviated data. So something is wrong. Maybe they wanted to enter 20 years at that point in time. They went to add extra 0 at that point in time. So you can remove any of these by doing some cluster, fit it to a curve, or use a hypothesis testing in order to address some of these concerns that you find in your data. So how can you remove some of these? You can plot a graph. Visualize your data first. It will help you to look at it. So do an R-pairs plot or do a Python pandas 2 plotter scatter diagram. It will give you an idea of outliers in your data. Let me show you examples of some outliers. Here's an outlier. You can see in this particular record, you see these things we have here, we refer to them as outliers. They are away from the clusters, as the case is. This one too is another example of an outlier that's far away from the clusters that we have. So depending on the kind of scatter diagram you plot, it will show you outliers from the data. Other examples of outliers is something like this. You can see this particular data points that we have here. These are outliers. This one here, these 3 here are outliers. And this one too at this extreme end is also outliers. You can see that these other ones here are the ones that are consistent with the expectation with minimal variations here and there, to be able to help us to understand the data that we have at that time. So that's how you deal with data outliers and errors. Other kind of outliers that you may see and deal with, all right, is in being able to, I'm sure some of you are familiar with this, you can trim in Excel. You trim any data that is outside a particular figure or a particular value. So those are how to address that. Or you can use a substitute. Any error you find, you substitute it. Or if you see one that is below what you expected, you can interpolate, all right? Or censure, right? And remove it entirely at that point. So those are some things you can do in order to deal with your data. Again, let's share a formula on how to do this. So when you're removing outlier, if you're using R platform, you do data frame filter expression. So you give it the expression, what should it filter out at that time? Here's an example. So library display, from the frame 1, it should filter from the column, anything greater than 40, filter it. From column 2, anything less than 30, filter it out. From column 3, anything less than 3, filter it out. So you can use the filter expression in R to be able to remove outliers that you don't want. How about Python? If it is Python that you're using, again, you do data frame, still use the same thing, filter expression. But note, in R, we use dots, but in Python, we use underscore to be able to drive at that. And there's dot between the data and filter frame, and there's no dot here. So here's an example. So again, in Python, we say for the frame 1, column 1, anything greater than 40.0, filter it out. Anything in column 2, anything less than 30.0, filter it out. And anything less than 3.0, you can filter it out at that point in time. So those are some of the things you can do with your data analytics in order to filter things out and then close it out. Now, our last topic today is on the Matplotlib and Pandas. So this is focusing on Python, all right? But you need to install the extensions, the Python extensions on your system. And if you don't have it, when you receive this particular material, you can go to the website and download the extensions that you need in order to run this analysis. It can help you to run any of the analysis that we've said so far. There are other resources. You can go to the website and download it, or you can go to there are various platforms where you can get the files that we've used to run this particular analysis. And then you can filter them based on those platforms. So once you're done with this, the next thing is you can begin to do, based on some of the things we've shared so far, you can run some analysis. The Matplotlib is a collection of routines and functions that you can use for data cleaning and data clearing of anything that you have on your data, so you can wrangle the data and it will be ready for result. Here's an example of Matplotlib that was used in order to plot a basic data. And when we plotted this data, it is looking like, so any occurrence of data outside this, right? If you visit this site, you can see tutorial of how to plot these particular graphs. It is easy to plot, simple command, and it will show you the graph immediately at that time. Other functions you will find in this particular platform is you can draw line charts, histogram, bar chart, pie chart, right? Legend. You can do scatter diagram. You can do 3D scatter diagram or scatter plot using the Matplotlib. And it is very easy. Just install Python on your system. If you're using a Microsoft application or operating system, or if you're using a Mac computer, you can install a holding system and then use that to run it at that point in time. Same conversation we can have. There are libraries in Pandas that you can also install, and then you'll be able to use it. If you're not used to Pandas, just run this routine, 5-10 minutes. You will understand what the Pandas does, and then you'll be able to achieve it very, very successfully. At your own convenience, you can do a hands-on exercise, all right? So here are some files on forest fires that you can use to do an analysis. And then you can find out how to clean the data sets that are there. So identify which records are empty, which ones have different locations that you cannot use. If you'd like to watch additional video, specifically on data wrangling, here are 2 videos that you can watch. From YouTube, there's data wrangling using SQL, if SQL is what you're used to. And here is data wrangling using Python and Pandas. Any one of these YouTube videos can help you to be able to understand and wrangle some of the things we've mentioned in detail as the cases. So you can prepare your data and it becomes much, much useful to the endpoint and be able to do your analysis at that point in time. So this is where we come to the end of our discussion today. If you have questions, you can please share on the chat box, or you can unmute yourself before we share the extra resources that can help you to do more. Meanwhile, in another 1.5 weeks or thereabout, we have an upcoming Power BI business analytics program coming up. You can turn data into beautiful business decisions using Power BI. This course introduces you to Power BI, how to model data, how to visualize data, how to do data analysis with Power BI, and to manage the various data sets and workspaces. Embedded in it, in one of the modules also, is the practical aspect of what we've covered so far on how to clean data. This course is very useful if you are a business analyst, if you're a professional, you work in finance, you work in HR or operations, all right? And anyone who is into analytics, you can also get involved with this. This particular program runs this particular month, and you can get involved with it so you can understand Power BI very, very well as a tool you can do analysis with at that point in time. On the 21st of February, we also have a data analytics professional summit where you'll be meeting a lot of professionals who have advanced in their career in data analytics. They'll be sharing a lot of interesting insights into data analytics. You look at trends, you look at how to build your path to become a successful data analytics professional. Please register if you haven't registered already, and it is for free, all right? Just visit, it's right there. I'm putting it on your chats immediately. Just visit the website and you'll be able to register for this particular summit. It's free, so you can be a part of it. It's a half-day session between 10 o'clock and 2 p.m. There are about 4 or 5 speakers speaking in various areas. They look at data literacy, they look at the various key skills that you need and the certifications you need in data analytics. They look at industry trends, they look at how you can build your foundation in data analytics, right? And how to build a strong portfolio of data analytics that you can show that you understand data analytics. And then it show you various individuals you can network with and build your analytics career at that point in time. So try and register and join this particular free session down the line. Some of the good things that will bring to you as an organization. Thank you very much. If you have questions or feedback, we will take it. Otherwise, I think this is the end of this particular session. I'll hang on a little bit in case if you have questions or feedback, any questions, feedback, questions, or any information you'd like to know. Once again, this particular session is brought to you by P4PE Institutes under the brand name P4PETalks. All the content that we presented so far as at today is as accurate as possible, right? Some of the information we've shared may change. You know, the days we're in a highly fluid economy where data continues to change. Some of these informations will change, but it's important that you get on board today, get used to it so you can learn and benefit from it. Thank you very much for your time. I'll hand over back to Jane. Thank you.
All right, thank you everyone for joining the session. I hope it was impactful. We've learned a lot. Please, if you have questions, if you have comments, please feel free to reach out to drop your questions. I've also sent the evaluation form on the chat box. Please help us through the evaluation form. They say feedback is the breakfast of champions, so we can improve on what we are doing. Then we'll send you the link to the recording of this particular session. Then if you want more than the link, you want the materials, you can still reach out to us. Thank you very much once again. Please fill the evaluation form for us. Thank you.